Welcome back, everybody. Welcome back to the channel. So I know the title of this video is going to be how to parse try-catch statements, but we're actually going to be talking about how to parse lock statements as well. So we're going to do this one first. Lock statements are pretty simple, so we'll just start off with this one and then we'll get into parsing try-catch statements. But before we even get into that, if we look here, like we're pretty much almost done with parsing statements. Like we've already done continue statements, go to statements, all that good stuff. And we have one, we're actually not even gonna, I'm not even gonna show you guys how to do ASM statements yet because it doesn't really make sense to talk about that on the YouTube series. But yeah, I mean, we just have like one more statement, when statements, and then, I mean, I'm just gonna explain this for like 5 minutes in the end of the next episode, and that's gonna be it. So now let's see how lock statements work. So we're gonna have our is statement as usual. We have our lock. And the concept of lock statements, if you guys have ever coded in Java before, it's basically like synchronized in Java. It's the exact same thing. So with lock statements, you want to, of course, make sure you block access declarations, return true. All that stuff's pretty standard. And once you get into the parse lock statement function, you want to create your AST lock statement as your branch. You want to minus minus the current token and process lock. And of course, you don't need any of these tokens, so that's why I set them to false. All you need is this is what's going to be considered as your condition expression. So what we're basically saying is lock whatever expression that is returned from here, so that way it's thread safe. We're going to create a multi-threading system for our programming language, and when we get into doing that, we're going to basically be able to allow the user to basically use mutex locks at the language level. So effectively, all this is just a mutex lock. Not really gonna explain what that is. You guys can kind of look it up. We'll go over mutex locks and stuff later on, but that's what that is. And then after that, use parse block, and that's pretty much it. Lock statements aren't too complicated, but on the back end, it's a huge pain in the ass. But once we get here, we can see now we have the is try catch statement. So of course, after that, you want to create your is function and look for try. And once we do that, same thing as usual, block access statements and return true. Once we get into there, we can see we have our try-catch statements. Now, if you guys have ever programmed in an object-oriented programming language before, you know that with try-catches, there's three parts. There's the try, there's the catch, and then there's the finally. Finally is assumed to execute basically regardless of whatever the heck happens. So whether there's an exception that gets thrown, or whether the user exits the scope, or whether they return, that makes building this stuff on the back end a enormous amount of work, and it's just really complicated. So, but we don't need to worry about that right now. All you need to do is just basically create this AST try catch statement, decrement the current token, parse try, expect the try token, and then of course you don't need to add it, parse a block, and then we're going to need to parse what's called a catch chain. Now, I'm sure some of you guys have seen try catches before, but just in case, I'm going to go in here, go to syntax, and here I'm going to create init, and we can go in here. So what we're, oops. So basically, we have try, and let's say we throw an exception, and I don't know, error. And when we throw our exception, that's going to basically require us to catch it. So you can expect to catch multiple things. So there's going to be two formats for catching exceptions. So you're going to have the catch and you're going to have the parentheses. And you can basically, this is why it's called a catch chain. You can chain multiple, why is it the formatting so bad? You can basically chain multiple catches. Okay, I'm not going to keep pasting this, but you can chain multiple catches to a single try. So what that effectively does is that tells the compiler, well, first let's try to catch, I don't know, um, bounds and index, or no, what is it called? Bounds, B-O-U-N-D-S, except. So we can catch a bounds exception, or basically an out of bounds exception. This is shorthand. I actually have, where is it at? In my standard library, I have an exceptions file that I'm still working through, but it has like all the various exceptions, thread stack exceptions, stack overflow, runtime exceptions. But you can see down here I have a bunch of aliases, and bounds exception is this one. Yeah, so it represents index out of bounds exception. But so that the user doesn't have to type all this crap, I just use bounds except as like the shorthand for that. So we're going to have two main formats. So first of all, like when we throw the exception, we're going to try to see, is the exception the exception we're trying to catch? So it's not a bounds exception. And with exceptions, you have to have the exact exception, otherwise it's not going to work. It's not like where you can have like a function called, I don't know, foo. So if we define a function called foo, and it has a parameter of n of type int underscore int 64, and I can call foo um, and basically pass, like, let's say I have I of underscore int 8, which is a completely different type than int64, even though they're both numbers, and I can pass I in here and it would still work, right? Because the compiler can resolve this information as, oh, well, we don't have a function that has the type of int 8, but we do have a function that's the type of int64, and considering that these are both numbers, this should be fine to call this function because those types are related to each other. But in this case, for try catches, that doesn't happen. So you need to have the exact exception. So for this case, I'll also say exception. And here's where you see both formats. So you either have the format where you have the name of the variable and the exception you're trying to catch, or just the exception you're trying to catch. Because sometimes you just don't need to have like the variable here. You just want to catch the actual exception and do something about it. But yeah, so the user has two options, so we can see what happens with that. All right, so where the heck is it? Okay, so we're going to look at the catch chain. And basically what we do, and catches, by the way, are not required. However, if you have a try catch, you either need to have one of two things. You either need to have a catch, or you need to have a finally at the very end of the try catch. Or you can have both. So you can have a catch, a try, and a finally. So you can have either one or the other or both. Doesn't really matter, but you need that specific format. So we check to see if the next token is equal to catch. If so, we parse our catch clause. And then after we parse our catch clause, we check to see if the next token is equal to a catch. If so, parse another catch clause and go back up to the top, rinse and repeat. You guys know what this format is. I do this everywhere else. So let's look at the actual catch clause function. Overall, not too bad, I don't think, in terms of like the parsing syntax. So we have our AST catch clause. We expect the catch symbol. We expect the left curly, and then we expect a parse utype arg optional. So that's how we can allow the user to either specify, hey, I want to create this variable because I don't know, maybe we want to do something with this variable. Maybe we want to like print out the stack trace of this bounds variable here, or maybe we want to like do something else with it. But in this case, for this one, we won't have a variable to access or do anything with, so we just catch the exception and move on. So that's kind of how that works. So that's why we have our parse type arg optional. After that, we parse our right paren. Of course, you don't need any of these tokens, so you just say return false, or you say false for the add token boolean, and then you just parse a block, and that's it for catch clauses. So if we go back up to catch clause, where let's go back, and then we go back to parse catch chain. Okay, so now we're here. So we've successfully parsed a potential catch chain, and then we need to parse a finally block. So once we do that, we check to see, again, finallys are not required. So we check to see if the next token is equal to finally. If so, then we basically parse a finally block by creating this AST finally block. We expect the token finally, and we parse a block, and that's it. So with all of that being said, here's how I basically check to see whether or not we have one or the other. So I check to see if the current branch has a sub AST of AST catch clause, which would be, so you'd see this here. So like it wouldn't be AST catch chain because there's no AST generated here. It would be catch clause. So we generate a bunch of these ASTs, and that's going to be printed underneath the branch that we pass in because we just pass the branch directly in here, and we don't create another branch. We just pass that AST directly into here. So we can guarantee that those catch clauses will be created under this branch. So we just check to see if we have either a catch clause branch or a AST finally block branch. And if we have neither of those, then we want to say expected catch or finally, because we want to make sure that the user has one or the other. So that's going to be it for that. And yeah, that's pretty much it. So let's actually see the formatting for this. So I'm going to have catch, finally, and then lock. So I'm going to create a variable here called objects, and let's assign it to, whoops, assign it to a new int. So int of 100, and then we can lock object and do something in there. So let's say I is equal to 0. All right, so we can see here if we go back, so we can see how all of this code kind of looks together. So first we have, it's going to be a lot of code actually. So we have our try catch statement, which has a block of one statement, which makes sense, is just a throw statement. And we can see here we have our throw statement of a new expression of exception. So that looks to be good. Then we have our expression list of error, which is for the new expression. So then we come down here. Now we have our first catch clause. So we have our utype arg of bounds of type bounds exception. And we have our AST block of nothing because obviously it doesn't have anything in it. Then we have our second catch clause without a parameter, name. It just has the type of the exception you want to catch. And then that basically is just a utype of an exception. So we don't have any tokens here for the name of the variable. And of course we have an empty block there, and our finally block is also empty, but that's important so that we have that. And finally we have our lock statement. So we have our lock statement of AST expression, and that expression is basically just object. So we basically want to resolve this expression on the back end and then check to see if this is something that's considered to be quote unquote lockable. We'll go over what lockable expressions are later on, but that's what we basically check for, and then we basically parse the block immediately afterwards. So we parse our block of a variable declaration where we're assigning 0 to the variable of I. So everything looks to be good here. This is just other stuff that's generated from my standard library. I got other code that has lock statements and try catches in it. So we don't have to go over that noise, but yep. So that's going to be it for today, guys. As usual, if you guys have any questions, definitely put them in the comment section below. Also, if you guys would love to help support the channel, definitely head over to my GitHub repository at androidevcd/sharp. And when you do, definitely watch, and fork this repository. That's going to give this language a lot more visibility and let other developers know this language exists. Also, if you guys are interested in seeing what I'm doing on a day-to-day basis, then you can check out the remastered branch. And once you guys get there, you can check out the commits. I write some pretty wordy commits, so you can kind of get a gist of what I'm doing without really having to look too deep into the code. Also, if you guys didn't see, the compiler is done. Well, for the most part. It's like, so before I think I put a commit where I was like 95% done. It's now like 98% done. But basically what this means is I no longer have to stall with these long ass YouTube videos. So I thank everybody for being patient with me. It's been a ton of work to kind of get this done. I've been like cranking out updates every single day for the past couple of weeks just to kind of move things along, I guess. So I'm going to continue doing testing on the compiler, but for the most part, it's pretty much done. So that pretty much guarantees that there won't be any delays, and once we finish statements, we can just continue going on with the series. Also, if you guys are curious about learning maybe stuff that I've done in the past to the language, or maybe stuff that I'm looking to add into the future, you can check out the docs folder in the remastered branch. And when you get there, there's two main files. One is the changeless file. This isn't really updated. As you can see, I update the roadmap file pretty frequently, but the changeless file is basically just old updates, like anything that I did to the language in the past for like previous versions or releases. And the roadmap file is pretty much everything that I not only have done in the past, but also stuff that I'm looking to add into the future. So definitely recommend checking out this file. Gives you a lot of insight into the language. And yeah, so that's going to be it for today, guys. As usual, if you guys are new to the channel, definitely consider subscribing. And until next time, I'll see you guys later.